Alright guys, you guys all done with the warm-up? Alright.
Ever forget your permutation for your lock? Anyone? No?
Yes.
Yeah?
All the time.
Permutation. You know what permutation is?
No.
Okay. This is actually a combination lock, right? Everyone calls it, oh, it's a blank combination lock. Don't tell me, because that's actually the wrong word that they're using. Combination, the order doesn't really matter. What is a permutation? What is a combination? I don't know. Like, what is a spike lock to you guys? Like, what do you do? Like, when you're trying to like put it in, like you have a bunch of numbers. Does it matter what order of numbers you put into it?
Yeah.
It does. So if I were to have like a combination of 0, 0, 0, 5, would it matter if I put the 5 first? Like put 5 here, and put the 0 here?
Yeah.
Not opening. If I put the 5 over the middle part, that doesn't work. What if I put it all the way in its proper order? Oh, it actually opens. 0, 0, 5. So, permutation and combinations. That's what we're going to be going over today in class. This is a part of the overall scheme of polynomial and polynomial functions. It's a really cool thing that you guys can figure out that you have some really cool examples. Another example of perhaps a permutation would be, I don't know. Permutation is an arrangement of items in a specific order. So, with permutation, the order of stuff matters. Combinations, kind of like, what would be another example? What would be a combination? I'm trying to think of an example of what a combination would be. Like, a whole bunch of stuff put together.
6 green marble and 10 red marbles. Combination.
Like, to pull stuff out of the bag.
Yes, that's the combination.
That's one.
They're both marbles in different colors.
Yeah, and you can pull them out of the bag.
Different kinds of flowers in a bunch.
Yeah, it doesn't really matter if the daffodil is up in the front, or if the daisies are next to the dandelion.
Like a bowl of fruit.
Bowl of fruit, good example.
Types of fruit.
Fruit salad. Does it matter if you put the grapes in first, or if you put the apples in first? No, it's a whole mix. It's a combination of stuff. Cobb salad. Doesn't matter if you put the egg in, or the tuna in first. No, that's all like combination stuff. Permutation is like, well, how many people can line up in a row? Or, you know, if I'm using this combination lock, or excuse me, permutation lock, it matters if I have a 0, 0, I have a 0, a 0, a 0, and a 5, or a 1, a 2, a 3, and a 4. It matters that the 1 is in the first place, the 2 is in the second place, the 3 is in the third place, and the 4 is in the fourth place. So, alright. Moving on with that. So let's think, I'm not really going to talk too much about the combinations today, but what I wanted you to know is the difference between the two. Since we call this thing a combination lock, I can see how everyone might get confused that this is a combination, but it's not. Combination, order doesn't matter. So, today we're going to be learning how to count permutations. So, I just happen to have my kickball trophies that I happen to love so much. And, yeah, kick, get it? It's a boot. Kickball. And they're all really cool. And I want to put them up on my shelf at home. And I love them all. They're all really cool and I love them so much. I don't want to give my love to just one of them. I want to keep them on my shelf and I want to have one as my centerpiece, changing all the time. How many different ways can I arrange this on my shelf?
6.
6 different ways? How did you figure that out?
Because you showed us that the other day.
Ah, right, the multiplication counting principle. Huh? So, let's call boot 1, cup 2, ball 3, right? So the way that it's ordered from left to right, or for you guys, right to left, right to left. 1, 2, 3. And now let's rearrange it. Let's switch these two guys. 1, 3, 2. What else? This guy. So it's the order. Is that 2? 2, 3, 1. Two, 1, 3. And what else? We already did that one, right? This guy. So this, as you guys can see, this would take me a whole long time if I were to just keep on doing all these different ones. I'll just finish up the 3, 2, 1, and 3, 1, 2. So there are a total of 6 different possibilities. You got it. Because there are 3 different ways this can be on the left. And if this guy's already here on the left, there's only 2 left. So there's only 2 that could be here. And the only remaining one would be 1. So 3 times 2 times 1 leaves me with just 6 choices. Or, does anybody know what faster way we'd be able to write this out?
Little exclamation mark, right? Factorial.
So what's it say?
3 factorial.
No, it says 3! Get it? Sorry. 3 factorial. It's 3 factorial. So, 3 factorial is a way of writing a permutation, but some permutations are actually, you're not using all the sets. Say, I don't know, I had this other example of a permutation. I was with my mom, spending a little quality time, and I thought of this problem. So there's 7 dancers left on Dancing with the Stars, and there's first, second, and third place. Now, how many different ways are there for people to get first, second, and third place? Now, you're not actually using all the people. You're not using all 7 people. You're not going to figure out what 7th place or 6th place is. Huh. Well, we have 7 dancers, right? So what do you know about the multiplication counting principle?
You would stop after you multiplied 3 times?
After 3 times.
There's a ringer in the audience.
All right. Anybody know where I'd start off? Like, how I'd even begin? Perhaps.
I'm gonna guess 7.
Good call. 7. So there's 7 possible people who could be first. How many people are left to be 6th? Or, excuse me, how many people are left to be 2nd place? 6. 6 people left to be. And how many people are left to be in 3rd place after the first 2? 5. So that's one way, that's one method. But if I were to do like a huge, bigger number, there's another method which is a little bit faster, which is called the permutation formula. So this would give you the right answer. This is one method. I'll call this method 1. Method 1, which is just counting. The multiplication counting principle. Method 2 will give you the permutation formula. The permutation formula is this cool thing mathematicians all figured out, which is written like this: NPR, where N is the total number, in a set, and a set would be like what? The 7 dancers, right? In that example, or the 3 trophies that I have. The R is actually going to be what? What do you think? I have a guess. Thinking of my Dancing with the Stars example.
The ranking?
Hmm?
The ranking that they were going to get?
Right, the first, second, and third place. So the R would be more about things that are chosen, like how many people can get the first, second, third place, or how many books of 3 can I line up. So this would be the chosen number of things chosen. Alright. That basically is the permutation formula. Now, the example for the Dancing with the Stars, what would be our N? There are 7 dancers who would be first, second, and third.
So 7.
So it would be 7 P 3. There's 3 places, first, second, and third. And we would line this up where the N, excuse me, NPR is equal to N over N minus R. For us, that'll be 7 factorial over 7 minus 3 factorial. Which we would have. Factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. 7 minus 3 is 4. 4 times 3 times 2 times 1. What do we know? What cancels that?
4, 3, 2, 1.
We ultimately get the same thing. But in your calculator, which you guys have, if you have like a TI-84, you'll be able to find the answer real quick if you're able to just plug this in. So, you guys all have your worksheets, right? First off, is there any questions? All right. Go ahead. Get started on the worksheets.
I'm done.